All right, we're back. We're continuing our discussion on inheritance, moving into a topic that I quite like, a subtopic of inheritance, and that is abstract classes. We'll learn about abstract classes, do a little bit of coding, finally something new. We've been working with Person for quite a while, and then hit a recap. Every class we've designed and coded up to this point would be considered a concrete class. All right, so here I'm just adding some terminology. Every method in a concrete class has an implementation. It has a body. Additionally, client classes can construct instances of a concrete class, right? We've been making person objects, and all of the methods in a person have a body. They do something. In practice, however, the vast majority of class hierarchies involve an abstract class or an interface, we'll talk about interfaces later, near the top of the hierarchy. Consider every computer science textbook's favorite inheritance example. I promise you, if you Google inheritance right now, they're going to give you some nonsensical example about animals and dogs and cats. It is a good example because it illustrates the principles of inheritance and polymorphism, right? All animals move, but how a dog moves is drastically different from how a bird or a fish or a cat moves. So each subclass will want to override the move method, right? We have a central class, animal. It's got a move method. The way dog moves is different from the way a cat moves. Ultimately, so you see in this diagram, right, they are overriding the move method. The way the dog moves is different, so it's going to override it. The way the cat moves is different, so it's going to override. Ultimately, we can declare an animal collection. I'm talking like an array or an array list. And we can put all sorts of animals in it. Dogs, cats, birds, fish, right? They all have a common ancestor of animal, so they can all go into the collection. Then we can iterate over it and tell all of them to move, right? And that's where polymorphism kicks in. We can call the move method because all of them would have it. Dog clearly has it, cat clearly has it, but even the classes that don't override it would inherit this one. All animals can move. That's what this is saying. Yeah, I know my biology nerds are going to come in. Well, what about all animals can move in this implementation? Okay, so we could loop over the animal collection and say, whatever the current element is, move. If it's a dog, it's going to move the way the dog moves. We move on to the next one. Whatever you are, move. And it's going to move how it's supposed to move. That's the polymorphism, right? And the fact that we can put it all into the same array or array list, that's polymorphism. So this is not a terrible example, right? The way the dog moves is different than maybe how the bird moves. Here I have some nonsensical move methods. In practice, you would maybe visually represent these things, I don't know, in a simulation. But what about the move method defined in animal? This is where this falls apart and why I kind of hate that people use this as an example. What does the implementation of this one look like? How does an animal move? Just a generic animal. What are you going to put here? It's hard to answer the question because realities are you shouldn't provide an implementation to the move method in animal. In Java, a method can be declared as abstract using the abstract modifier. A reminder on our method syntax, like our method header syntax, all of the modifiers go up front. Then we see our return type, our method name, our parameters. There's a note here that says modifier order does not matter. I may have spoken about this before, but you can, so modifiers that we know, public, private, right? Those are access modifiers. Another modifier we know is static. What this is saying, what this note is saying, is that you can actually say static public int, right? You can do static public, then your return type, as long as the modifiers all occur before the return type, their order does not matter. Now, in practice, I've never, ever seen that actually happen. Only in academia do we do such nonsensical things. But abstract is a modifier that we're learning right now. And it's up here with the modifiers, right? I have my access modifier of public. I then have abstract, then my return type. Okay, let's break this apart because you'll notice I have something here that is typically a no-no, a semicolon at the end of the header. We could say abstract public. Nobody does that. Okay, so abstract methods don't have a body. They merely exist to provide a method signature. This is going to click, I promise. If a class defines one or more abstract methods, the class itself must be declared as abstract. So not only is the method going to be tagged with abstract, but we're going to have to take our class, right? The moment that we have an abstract method in our class, we need to make the class itself abstract. Okay, modifier order technically doesn't matter here either. But because I have an abstract method is simply one without a body. We're doing this in animal because the move method, right, in terms of what should go here in the body, what should the implementation be, nothing. There's nothing that we could put here that would be like superb, that would just be ideal. So instead of putting some nonsensical body here, I'm going to do nothing. I'm going to tag the method as abstract and leave off the body. The moment that you have an abstract method in a class, that class has to also be abstract. Okay. This is a modifier, which is why it's going in front of the class. And, this is all about abstract classes. So that should help you a little bit with the order of these things, right? This is public abstract class. This is an abstract class. Okay. So in terms of our UML, which we will use these things to kind of keep track of what we have written, this is italicized. It may be hard to read, and in practice, I couldn't italicize things on my whiteboard. How do you make, when you just slant real hard? So, but on the UML diagram, things that are abstract are italicized, right? This move method, that's an abstract method. It's italicized. Because we have an abstract method, the class has to be listed as abstract. So animal is also italicized here. Note that a class can be declared as abstract without defining any abstract methods. We can have an abstract class that doesn't actually contain abstract methods. That's okay. I'll talk about why that's a good idea a little bit later. Additionally, an abstract class can declare instance variables. We can define constructors, and we can have concrete methods. So an abstract class can be a mix of these things, right? We have the instance variables, constructors. These are concrete kind of elements. Same thing with, of course, concrete methods. And what this is saying, what this slide is saying, is that we can have a mix of these things. We can have instance variables. That's a concrete thing. We can have constructors. That's related to the instance variables and thus a concrete thing. We can have concrete methods. That is, methods that have a body. This slide is kind of showing this off, right? Here, animal is an abstract class. It's ultimately abstract because we have an abstract method, the move method. But what I can also do is come in with some concrete elements and mix those in. I have an instance variable, a mass. Because I have an instance variable, I got a constructor that helps me initialize it. Down here, I've got a toString, and it is a concrete method, right? It is not abstract. It does have a body. It does have an implementation. That's what a concrete method is. Any class that extends an abstract class must override the abstract methods defined in the superclass or be declared abstract as well. I think we should start coding to really hammer this slide home. I'm in IntelliJ, and I'm going to make a new project by going to File, New Project. I need to switch to my CSA folder. I'm going to call this one Animal. I'll expand my project folder, right-click on the SRC, make a new class, which we were going to call Animal. Okay. Let's go ahead and code in some of this stuff. I'll get to the stuff we know, right? I'm going to go ahead and plug in a mass, right? All animals have a mass. Private double mass. The moment that we have a instance variable, we can alt insert a constructor. It's going to ask me what instance variable I want to use. I want to use this one. Boom. Okay. We could alt insert a toString. It's probably not going to be what you like. We'll come back to this little part right here. We'll revisit some tricks that I've shown you before. But so far, so good. This is just a concrete class. I've got an instance variable, I got a constructor, I got a concrete method. Okay. I'm going to hammer home a point, which is public abstract void move. I'm going to plug in an abstract method. Right away, IntelliJ's mad at me. That is because we have an abstract method and a non-abstract class. So the moment that we have an abstract method, we also got to make the class abstract. Okay. Everything's happy, everything's jiving. Now, what I would like to kind of talk about this slide right here just for a moment. A class can be declared as abstract without defining any abstract methods. What if I come in here and get rid of this bad boy? Notice IntelliJ's happy. You can do this. I'll talk about why you would maybe want to do this a little bit later, but just note that the order matters, right? Like this is only abstract. It only has to be abstract. Syntactically, it only has to be abstract because I have an abstract method. Now, a reminder, why do we even want this? Well, animal is a very generic thing. There is nothing I can put in this move method that'll make sense for all animals. So why put anything? Instead, I'm going to put in a header, which is going to give us a method signature. Why do we care about the method signature? We'll answer that question in just a moment as well. All right, so the last slide that we looked at, we saw said, any class that extends an abstract class must override the abstract methods defined in the superclass or be declared abstract as well. Let's make a new class. I'm going to right click on the SRC and I'm going to make a new class called dog. I want dog to be beneath animal in my class hierarchy. Immediately it's mad at me. Bruh. Let's scroll over this. What does it say? Class dog must either be declared abstract or implement abstract method move in animal. So the latter part's what I want to talk about. This is something we do want to do, right? We know animals move, or dogs move in a very specific way. They run on all fours or whatever. So I'm going to give an implementation. This logically makes sense. I know how a dog moves, so I want to override the move method anyway. So we're actually going to do that, right? Keep in mind, in order to override, we have to have the same method signature. What I'm overriding is the move method. That's what I have to override. This signature here is public. I'm not going to tag it as abstract, but void move with no arguments, right? So public void move. Now it's mad at me for a different reason, but I have satisfied that abstract thing. We are now overriding the move method, right? I would give it maybe an implementation, run on all fours. Okay, what is this mad at me for now? There is no default constructor available in animal. So with dog, I would bring in more instance variables, right? A dog is going to have, something like a breed. A dog is going to have a fur color. And with that, I would want to alt insert a constructor. The moment you have instance variables, you can start auto-generating code. I'm going to alt insert a constructor here. It's going to ask me what instance variables I want to use. Breed and fur color for sure. Okay. It also added in the mass for me. And now we're happy. Why? Because I did not previously have a no args constructor. What do I mean? If I take my constructor back out, right, there's no default constructor available in animal. right? When you don't write a constructor, keep in mind that Java is going to make you one. It is making this noargs constructor, and that constructor is calling the super noargs constructor, because that's how this is kind of happening behind the scenes, and this is happening implicitly there. But the problem is there is no constructor in animal that is noargs. Right? It's got a very specific one that takes in a mass. So that's why all of that was mad at me. I'll bring all this back in, right? How many instance variables is a dog going to have? 3. We're going to have the mass, which we inherit from animal, as well as a breed and a fur color. First thing that happens in my constructor is I need to initialize my mass. We don't have direct access to that because it is private. So we'll pass it up to the superclass constructor. The superclass of of dog is animal. So we're calling the superclass constructor one that specifically takes in a double. That comes in. We get the mass initialized for our dog. We then flow control comes back here where we initialize our breed and our fur color. Okay. Let's do our toString while we're here. If I alt insert one, it's not great. Right? It doesn't even involve all of my instance variables. It doesn't have my full state because we have a mass. So this is why I typically don't alt insert my toStrings. I want to ultimately call this one up here. Okay. So our slides actually hinted at using getClass for a moment. What's going on here? GetClass is something that we learned in a previous video where we talked about the object superclass. And this is a way to figure out the runtime data type of the object. That's literally going to, like if I was to print this as a string, I'm going to get the word class along with the class name, the object's data type. If I do get name, it's going to get rid of the class thing and just give me the name of the class. So I'm recommending that we put this in animal. Right? So whenever we call our toString, we're going to do get class, get name. Okay. Cool. So what that's going to say if we have an animal is animal, literally the word animal. And then I would want to include things like the mass. We'll do a colon mass, another colon, something like that, or maybe, I don't know, animal hyphen hyphen. And I'll tack on my mass. All right, I'm making these changes in my animal because I want dog to call the super toString. Okay, why? Well, I want to get my mass involved here. In reality, my animal toString already takes care of that. We'll finish this out and we'll actually go make a dog. All right, so let's tack on our breed. Do I want to do a new line? It's hard to tell. I'll just keep it all in the same breed, plus my breed. And fur color. Plus my fur color. All right, let's make a dog, and we'll see what we got so far. I'm in my driver. I'm going to PSVM to get my main method. I'm going to create a dog. I'm going to create a dog with a mass. What unit? You know, mass units. A breed, we'll say husky. And then our fur color is white and black. I'm going to print off my dog, and we're going to see this toString in action. Then we'll get back to our conversation about abstract classes. Dog. Mass, 123 mass units. Breed is husky, fur color, white and black. That looks pretty good. I'm going to put a space here. And by here, where's this coming from? Right? Where's the word dog coming from? Well, that's actually coming from my animal toString. Oh, replaced everything with a space. Brilliant. So let's take a look at the flow. When I execute my program, we start here. We create a dog, right? This is going to call the constructor for dog. We go into dog. First thing that happens there, we call the superclass constructor. Well, that's an animal. So I hop up to animal. We set the mass. Control goes back here where we set the breed, the fur color. Control goes back here where we have our new dog created and initialized. Then I'm going to print off dog. Right here, I'm actually calling the dog toString. So we go over to dog. First thing that happens, it calls the superclass toString. That's an animal. First thing we do here, we call getClass, which is going to give me the runtime class of the object. In this case, it's a dog. Okay, we do the name of that to get rid of the class thing. Let me show you what would happen if we didn't do get name. Hopefully, I don't think this is going to break it. I don't normally do this. I think it should just say class dog, right? Yeah. I don't like the class. You could do some substring magic in order to get rid of that, or just do get name like an adult. So we'll get the class, which is technically a dog. We'll get the name of it. We then tack on our mass. Control goes back to the dog toString, where we tack on our breed and our fur color. That gets returned, and control goes back to here, where we actually print that. So this is pretty sleek, because even though this was a dog, my animal was able to figure out the runtime data type of that. Okay, let's add on another class. What do I normally do? I don't know. We'll do bird. What does a bird have that's unique? Bird things. Number of wings. I'm going to extend animal in order to get this into my class hierarchy. No, what's wrong? If I scroll over this, bird must either be declared abstract, we'll talk about that later, or what we want to do, implement abstract method move. Okay, we are extending. Any class that extends an abstract class must override the abstract methods defined in the superclass, or be declared abstract as well. We'll come back to this one. Right? We need to override the move method. That's what we want to do anyway. Right? That's what logically makes sense. I don't know how an animal should move. That's why this is abstract. I do know how a bird should move. It's going to flap its wings. So let's override that method. Right? The signatures need to match, so we're talking public void move. Boom. Technically, I have solved its problem. Right? This one's related to the constructor. I'll go ahead and finish out the constructor to prove the point. I'm going to alt insert a constructor. It's going to ask me what instance variables. I want a number of wings. Isn't that just? I got a better one. Boolean can fly. There's some birds out there. Can't do this. I'm going to alt insert a constructor. Gosh, I just amazed myself. So notice this is happy now, right? Previously, I was trying to call a no args constructor an animal, and such a thing doesn't exist. Now I'm calling the constructor that actually does exist. Boom. Okay. So let's actually give this, an S out where we say flap. Ooh. If we can fly, we're going to print off flap wings and soar. Otherwise, we're going to write run like an idiot. All right, last thing I'm going to do is bring in a toString. We have learned our lesson about alt inserting a toString. So I'm just going to write one real fast. We'll do public string toString. First thing I'm going to do is call the superclass toString. And then I'm going to tack on my canFly instance variable. Let's make a bird. I'm going to flip over to my driver. I'm going to create fly. I'm going to create a bird called bird. It's a new bird that can't fly. Oh, it wants a mass first. 7 false. All right, I'm going to print off my bird. And there we have it. Oh, look at this. When I go to create my bird, right here, we are calling the bird constructor. First thing it does, call the superclass constructor, passing in mass. That initializes the mass for the bird. Control comes back here. We initialize the canFly variable. Okay. Control comes back here, where I save that in to my variable. We then call bird.toString. First thing bird's toString does is calls the superclass toString. The superclass of bird is animal. So I'm going to hop to animal. We're going to do get class, get name. The runtime data type is bird in this case. So that's what get class, get name is giving me. We're going to tack on our mass, and control goes back to bird, where we tack on canFly and return that, where control goes back to our SOP, where we finally print it off. So that super.toString in combination with the get class, get name is pretty powerful, right? We like that. Okay, why even have a common ancestor? Why do we want to do this? Because I can then create an array list, any type of collection, an array of animal. I'm going to call it zoo, and we're going to make that a new array list of animal. Okay, I'm going to take my zoo. We're going to add our dog. We're going to add our bird. Now, I have all of my animals in the same collection, the same array list. Notice IntelliJ is not mad at me, right? The data type of this is an animal. The data type of this is not animal. Yet I can put them into my animal array list. Why? Because animal is an ancestor. That is, dog is an instance of animal. That is true, right? If I do an S out on this, I should get a true value here. Doesn't do anything, but I get a true value, right? Because this is true, dog can go into animal. And because bird is an instance of animal, it can go into this array list, right? So instance of is what dictates that this can happen. Instance of means that bird is equal to or beneath animal in the class hierarchy. Notice I'm not using the word subclass, superclass, because as we're going to see, you can go several layers deep with that, right? Maybe we got something in between animal and bird, which we will. Maybe we got something beneath bird, like more specific birds, ones that can fly and ones that can't. Penguin maybe fits into this, okay? But I have added both of these objects to my animal array list, despite them not being animals. That is why we want the inheritance factor anyway. That's why we want the common ancestor. The whole point in making this abstract, however, is that how does an animal move? It doesn't. There's no good implementation for this. Yet all animals can move, at least in our implementation. Shut up, biology nerd. So I'm going to loop through my animals now, right? For each animal, an annotated array, animal, which I'm going to call animal in my zoo. Check it. What is the compile time data type of animal? It is animal. The compile time data type dictates what methods I can call. When I do animal dot here, I don't see anything about breed. I don't see anything about can fly. Mister, you didn't write those. Yeah, I did. Look at them. Here is getters and setters. There's some there. Oh, what did I just do? There's a getter and setter there. Oh, just the getter. Cool. Right? When I do animal dot, I don't see anything about breed. I don't see anything about fur color. I don't see anything about can they fly or not. The only things that we can call are animal methods. Right? The most important one being move, other ones being object methods, right? Because keep in mind, this is actually extending object implicitly. So we can call the object stuff that got inherited down. We can call the toString method, well, technically got inherited, but look at one that we can call right here, move. Why can I call move? We got a signature. I'm going to do animal.move. I'm going to tell this bad boy to run. Let's get these other things out of here, just to clean up our output a little bit. Run on all fours. Run like an idiot. Okay, this is coming from the dog move. This is coming from the bird move. Okay? Animal itself didn't define a move. Let's piece all this together. The move method in animal is abstract. Why? Well, realities are animal is kind of an abstract concept. There is no physical thing called animal. In my actual program, I'm going to have dogs and birds and cats and camels. I would never make something called animal. It's too generic. It's a category almost more than anything else. I want the data type so that I can put all these things in the same array list. Now, when it comes to the move method, well, all animals can move. I need the method signature to exist so I can do this. The compile time data type of this thing is animal. We can call the move method because there is a signature. Now, that move method doesn't have an implementation. It doesn't have a body. It is abstract because there is nothing ideal that I could put here. There is no implementation I could put here that makes sense. In a related manner, notice that every time that we extended animal, we had to override that abstract method, right? So this forced us to write implementations, which would make sense. What happens if we don't override? Syntactically, it's not a thing, right? We can't do it. If I come into dog and I comment this out, it's going to get mad at me. I syntactically can't do it. But logically, why does that make sense? What move method what are we doing in terms of move, right? Here I overrode it. If we don't override, we're going to inherit. I would be inheriting this thing. Well, that's a do nothing method. That doesn't make any sense. Right? So it logically makes sense that we are forced to override the move method because the one that we are inheriting otherwise doesn't do anything. Not only does it not do anything, it just literally doesn't even have a body. Okay. So we're going to connect more of this in our next video and talk about some of the other things the slides managed to kind of glance on. And we'll hit our recap in the future video. I'll see you then.